All right, good morning, everyone. How we doing? Hope everybody's week is going good so far. Um, so today we're getting back into the swing of things. We are simulating DNA as well as thioether rings on a peptide. So I did some work in the background uh, in the TLEAP program, and I think I figured out a way to, let's see if I can find it, add a linker to DNA through TLEAP. Um, so here I'm specifying the termini to be dA and dt. That way I can, see if I can show you. That way I can insert a linker. So it looks like this. So if you don't do this, for some reason TLEAP well, I guess there is a reason, but it automatically assigns this as like a terminal um, nucleotide base. But if you specify it to be like a regular sort of DT, um, then you get this ring that's open, which is what actually connects to the linker here. Then on the opposite end, you have this phosphate, which can bind this oxygen here. So what I'm trying to do is, like, I thought had it all figured out and it was gonna start simulating, but I'm running into this strange error right here. So that's what we're going to be troubleshooting for right now. So let me go here. Um, this doesn't really match. Given your command, you're heating, but your restart is that. Is the restart labeled wrong? Um, it should be that. But your restart, if the restart came from a different prompt type, you need to rebuild the modified system. Verify this mismatch. That shouldn't be the problem. Everything matches. So here we're specifying the parm 7, just that. Let me send it this. Here is MD out of the previous run. And yeah, so while that's going, so we're setting up a simulation with a thioether ring again. So normally what I would typically do for these thioether rings is simulate or parameterize the rings themselves. So just like take this whole ring and geometry optimize and get the charges there. But I had a meeting with one of my collaborators, and he was saying that you could just like um, connect the sulfur here to a dehydrated residue and then add like a hydrogen. And that would be enough. So that way you would get around like, say, like bigger rings, for instance. So like in niacin, which is a common, I think it's like a food preservative. But you can see that there are like these kind of huge rings here, which is kind of like unfeasible to parameterize. So we kind of need to figure out a way to like bond these directly to a dehydrated residue. So that's what I'm figuring out right now, like that. And I got TLEAP to work without errors, but there is a negative charge, TLEAP says, which isn't right. So I don't really know what's going on there either. So these are some of the things we're troubleshooting today. Heat watt.in. That's right. Parm7, min watt, RST7. That should be fine. Restart, yeah. Min watt. Yeah, all of this looks fine to me. I don't see anything wrong with this, but it's still throwing this weird error. It could be because the linker's too far separated, like I didn't build it properly. So let's open up PyMol. So here's our system right here. Let's remove waters. Turn on the sequence. We can delete these. And then maybe we can try and wiggle this around so that the bonding's closer. Oops. Like that. So what you do is create an object here. It'd be weird if this worked, because like I've done stuff like this in the past where it's not really bonded properly, but it ends up working fine. So I don't really know what's going on. Oops, let me do that. Move atoms. So you select this, and then you can maneuver it like that. All right, then we can hide a cartoon here. And then we need to rotate here. Oops. How do I do this? There we go. So it should be bonded like that. Let's get it back a little bit. I mean, that's as close. This is pretty much good. So we'll save this and try it again. PDB. I think it's called that. Save. All right. So we need to, where do we go? Not that one. I thought I had this open somewhere. I guess not. Oh, let review went okay. I was kind of short for time, but if you guys really want to, I can go through the entire presentation. just leave a comment and I'll do it. I do plan on emailing those guys and asking them some questions. Maybe I could record that if they are comfortable. That'd be cool. Do like a little interview. All right. So here, with some loading, which complex? Yeah, that one. So that's supposed to be bonded to that. And that already looks bonded automatically. Alright, so let's see if this works. I don't see why this would, but you never know. Alright, so what came out? Ions.pdb. Okay. Alright, so I'll open this. Modified. Yeah, so all of these files that were modified today need to get dragged over to the supercomputer, which is here. So it's all of these replace. Okay. So now we gotta go through minimization again. Binaries built without support pins. Okay. So on many clusters, that binary is built without netcdf support. When netcdf restart is read by none, he tries to parse it as a formatted text, then dies. Pick one. Run the heating with the same GPU binary that created the restart file. Like, I've never had to do this before. Okay, so what is the min watt? That's CUDA. And I believe heat watt was CUDA as well, but so I'll cancel this. All right. We'll wait for that to copy over. In the meantime, we can prepare the ligand system right here, or the ring system. I mean, right here. So this tleap script is kind of interesting. We're loading the dehydrated residue, and then we're loading like an unmodified ring. So I renamed the residues, the threonine residues, to the dehydrated form. And then here I'm removing the cysteine hydrogen and then connecting that to the bond it's supposed to connect to, the dehydrated residue. And I'm renaming the types so that they're sp3 and stuff. Then adding a hydrogen there. And that should work, but I don't know why it's a -1 charge. To me, it's fishy. Still going. So let's talk to Claude. Claude is honestly better. This runs fine without errors. I am trying to create a thiol ether ring using the dehydrated THR residue. The only problem is that the charge is predicted to be -1 at the end. Further, when we add the hydrogen, it automatically puts it at the origin. I am wondering if we are assigning the wrong atom types and if we can get the coordinates of the carbon the hydrogen is supposed to bond to, and then place the hydrogen in the correct place in space. So we have that, and then this is the output. Does this need anything else? I don't think so. Alright, so this is all loaded up. So we'll do this batch. The first one is min watt. Let me make sure the input is what it's supposed to be. Yeah, we're not putting restraints on anything. What does this say? Because the atom types aren't balanced after modifications. No, I don't want to do any Python shit. So we have to assign charges there. Alright, let's just run this and see what happens. Here. With HPDB. Why is it doing that? Set container parameter object. So it has the wrong syntax. Do we have to assign the charges? tleap help. I'll give it this. We should just be able to fix all of this in tleap. Here are some of the commands. Charge, help, charge. tleap is complicated, and there's not good documentation on it, honestly. What were we doing now? Oh yeah, checking this. So, you can go here. It's literally the same input scripts, and they work fine. So I don't know what's going on. So this one's heat watt.in. Where are we? Heat watt.in. And just to be 100% sure. Oh wait. No, that should be good. So these are changed, right? Yeah. Alright, so let's do sbatch minwatt.sh, double check. Looks right to me. Alright, hopefully this doesn't take a long time to submit. I mean, I'm only requesting 10 minutes for a GPU, so it'll take like 4 seconds. Added explicit charges. Is that really what we have to do? Z apply to coordinates of set matrix, molecule and fragment coordinates set. Like everything else works fine except for the charges. I wonder where that comes from. Maybe from the sulfur? Because here we remove, like, let's get rid of this. Does the charge go to 0? Okay, now it's giving me, I mean, I guess it gets closer. What other hydrogen am I removing? This is the only hydrogen I'm removing. On 46 Hg. Mm, placeholder charge. What if I just got rid of that? No, you need to have a charge. Huh. Illegal residue range specified in the network. What? This one seems closer to working. And relax doesn't do anything. No, this worked. Still have an unperturbed charge of -1 though. Relax for better convergence. You could just relax it multiple times. AA thioether. Yeah, that didn't work. Alright, let's see what happens if I don't relax. Is it further away? No, it looks about this. Well, I think there is some rotation there. I mean, we could look at the coordinates. So we'll have that there. And then we'll add back in the relax. Yeah, it's not moving anything. But it should be an HA atom here. Yeah, so there's the HA atom. Relax doesn't move anything. Why is it? This- Okay, thanks for the help. Relax, command, tleap. Okay. Like, can we specifically relax instead of AA, like AA 42? Is that a thing? I didn't change anything. 43, 42, 46. If I bump that up to 9, what does the charge end up being? It does change. Alright, let's look at this. Are we going yet? Of course not. Maybe we could look at, I don't know, this. So right now we're forming ring A. Maybe in the FRC mod file. S is or here. Is it S dot 3? Is that a thing? Nope, that's not a thing. Maybe if it's GAF 2. Nope. Um, hmm. Mm, I just don't know. I don't know how this stuff works. There's a .ac file. These look like atom types here. Okay, so maybe this could be something. So it's gonna bond here. What atom is this? This is H6. This is type H1. Yeah, it looks like we set that right. Is this the charge? Yeah. Um, it's a negative charge. So let me ask it. So when we change the atom types, we are supposed to change the charges of these as well. I thought TLEAP did this automatically. Why is it -1? Can you just submit already, please? It could be like the distance, maybe. Manages you're mainly changing atom types after loading, which creates a mix. When you load the PDB, TLEAP sum charges based on TLEAP. You change the atom type, but TLEAP does not automatically update the change. This leaves the original charge and prep and file with a new atom type. The real problem is that your ZDB has charges designated for dehydrated threonine, but after you form the thioether, those charges are no longer appropriate for your saturated system. You have two options. Let TLEAP handle if possible. Don't manually change charge types. Instead, create a new prep and file for the post crosslink ZDB residue with correct atom types and charges from the start. Hmm. Can I do that? Scale charges object scale factor. What I put? Put it at 1. I don't know. Hmm. The atom types don't really play a role since the bond linkage information is specified independently. Hmm. Let's see. Okay. Set res type nucleic. Head, tail. Hmm. Ugh. This is CPP traj, not TLEAP, right? Yeah. So this is a TLEAP script. Okay. So they're calling it this res type nucleic. So can I do set AA res type like amino acid? What are the res types? There's got to be a way to do this. I'll do tleap set AA set res type. Okay. Protein, there we go. Maybe I said it's protein. Like I almost feel like I would have had like have to be a developer to be able to do this. Like where does the -1 charge come from? Maybe I could do save mol 2. Is that a thing? And see what the charges are. Object file name. Oh, 0 for default atom types. Yeah, I'll do 1. Okay. Do we see the charges on here? We do. So their HA has a 1. Okay, what about ZDB? Okay. Then we have HA, which is that. Are we supposed to, yeah, we're specifying it to be that. So maybe I'll do this. So I'll copy this all the way to the cysteine. And then we'll see where the -1 charge comes from. We got 4 viewers. Welcome. Where does the -1 charge come from? I saved it as a mol 2. I should do that math. Still isn't loaded yet. I see the issue clearly. No problem, your SG still has a... After the cross, you need to adjust the sulfur charge to reflect the thiol ether, not the thiol. Uniformly scale all atoms so that the total is exactly -1 or use 0 if your system should be neutral. This is better than manually adjusting individual charges because it maintains the relative charge distribution for your force field. But it shouldn't be a negative charge. This is a neutral ring. So what is the charge of an RSR? Is that here? Am I missing a hydrogen atom or something? Oh, that's cool. It actually like shows you the bonding. Um, yeah, there should be a proton there, that's for sure. This looks ridiculous. CDB 43. Am I setting that to be? No. Scale factor must be greater than 0. The ring should be neutral at the end. What's up, man? How's it going? Or girl? I don't know what you are. The ring should be neutral at the end. Are we... Alright, did we submit this yet? Nope. Oh, you know what? Could be. What's the last residue here? Ter. So we should have an OXT. Wait. Should the charge be... Hold on. Maybe that's actually the correct charge, now that I think about it. Because the terminus here... Where are we? Wouldn't this have a negative charge? Are you simulating the higher order structure as well? What do you mean by that? Wait, should maybe the negative charge is coming from the terminal residue, the CCYS? I think so, actually. Yeah, there we go. Oh, wait. Never mind. The crosslink itself. Yeah. And met, yeah, so this should have a positive charge. Okay. Phosphorothioate bond. No, we are creating a phos or thioether bond. So for like niacin is one example. So basically we're trying to make this here, which I've technically already done in the past. Um, but my previous approach was essentially just like making this a custom residue, this entire ring, and then geometry optimizing it and calculating the charges and stuff. But for like bigger rings, that's kind of unfeasible to do that because there's like a bunch of atoms. So what I'm trying to do now is basically connect the bonds to a dehydrated residue and then add the hydrogen atoms and change the types so that it ends up being neutral. But it keeps showing us it as -1 for some reason. Perturb charge. What? Where did he get that from? I mean, maybe it could be like a side chain or something. Here's what we could try actually. So let's just do like the regular ass peptide and see what the charge of it is. Because if it ends up being -1, then it's fine. Um, so what do I need to do? Someone wants to meet with me. Um, isn't the isoelectric point dependent on the pH? Not sure what you're trying to do. The isoelectric point? I don't think that applies here. We're not really factoring in pH. So this is just like basically setting this up for an MD simulation. Okay. So I'm using Amber Tools. I don't know if you've heard of it, but it's basically like a program for preparing like molecules for MD simulations. And there's some like finicky stuff with it, especially with what I'm trying to do, which is like post hoc, like add these bonds together, and it's coming out with like a negative charge overall, which I don't know if that's correct or not, but I feel like I'm adding all the atoms together and bonding them. So what we really need to do, I think, is go to our AlphaFold server and then get out this and just parameterize this and see what the charge of it is. Because if it ends up being overall -1, then the charges are fine. That's complicated. Have you ever done MD before? On to, where are we? Here. Hell. Into, what program did you use when you did do it? Helm to, yeah. All right. Touch tleap test dot in. And then we can just do copy that, paste it into here. So all we need to do, yeah, we can do charge there. So we can get rid of all this stuff. This should be fine. So, like that. Charm, okay. Well, maybe actually you could help me out here then. So, let's see if I can find that paper. Because I actually do this in Charm. Do you know what a .stream file is? This is the paper I'm referring to right here. But I don't have access to it for some reason. Let me go through my email real fast. Where are we? Just 1 second. All right, here we go. I got the paper up. So this is what the paper looks like, and they're doing I think the exact same thing I am, where, so this is niacin, or niacin, I don't know how you pronounce it, but they parameterize dehydroalanine in Charm, and then they connect the cysteine to this dehydroalanine. And then they do provide this right here. So I don't know if you're familiar with this sort of file, the stream file, but they give the parameters. So this is for dehydroalanine, this is dehydrobutyrene. But I don't know how to use these for amber, or if that's even something I should do. My question is it, so like if you wanted to create a ring, right, in Charm, for instance, um, would your protocol be basically to parameterize this whole entire ring, or would it be to parameterize this dehydrated residue and then bond the sulfur to it? And then, do you know what a stream file is? This. Have you seen something like this before? And can I convert this for amber? um, what? Oh, okay. What's the overall charge here? Ah, see. So we're good then. What was the title of the paper? I need to look at the structure. Okay. Thanks for helping though. The new charm force field parameters for dehydrated amino acid residues, the key to lanthabiotic molecular dynamic stimulations. Turpin. Eleanor Turpin. But I think I just figured it out, honestly. So let me tell robot. Okay, so I just parameterized the peptide completely unmodified, and the total charge ended up being -1 as shown here. Therefore, the atoms and bonds I am creating do not add charge. Would this result from a potential side chain? And then I'll give it the sequence here. Here is the sequence. Okay, so I think we're good then. Um, let's go back to this. So the total unperturbed charge is that. It's pretty close. Good detective work. Okay, see? Okay. Bond. happened there? Yeah, okay. Bond atom. Wait, what? How's that wrong? Okay, so we'll do charge AA. So here it's -1. We do all these things, and it gets that. Okay. Is this your next presentation? No. I'm done with presentations. Actually, I'm not. I have to do my candidacy exam next month, potentially. So I'm going to work on that later. But this is just for research. But I think I did it. Okay, finally. So this submitted. And then the other thing that I'm simulating is a DNA linker. So there's someone in the computational chemistry class, and he's trying to add a linker to DNA. And that was a trip to figure out how to do that. Um, oh, great. Why does it do that? That's so weird. Like, I've never seen this error before. Invalid memory reference? And I think it works if I remove the restraint mask. Funny enough. Um, let's do this. In task 1. So get rid of that. You need to load these. Yeah, so I've been getting this error, invalid memory reference, which doesn't make any sense to me. I've never had that before. What if I do palm top? So this and reference should be the same. Oh, you know what? Is that why? No. Yeah, no, that shouldn't affect anything. messed up. Exited with code 1. Like, what? And then maybe I do INPCRD. Computers, man. No way. Now it's running. Is that really why? Oh my God. It's because I had these other things in there. That doesn't make any sense. Okay, hold on, I'm gonna try something. So what if I remove the in dot p crd, then I remove the dot prm top. Okay, so now I just have parm7 rst7 file in there. All right, let's see what this does. Nope. Okay. Well, I think we have our culprit then. So let's go back here. And so instead of parm7 rst7, we will do the that still doesn't make sense to me, honestly. Because these other ones just use parm7 and restart files. So why is this one? Save amber parm? Am I doing that? Yeah. So we'll do parm top. Maybe it could be like the version of amber or something. And INP CRD. Okay. So I'm going to remove that parm7. And remove dot rst7. Okay. And then I'll do the same here. parm7 dot rst7. Okay. Then remove dot md out. Okay. And then so I need to change that, but we'll do that in a second. Okay, open. All right, and then, oops. So we'll drag that over to there, replace. And then we'll change this to parm top, and then inpcrd. And so the reference is the -c. How does it do that? Right? Okay. Now it's being funky again. Is the reference the parm top? What happened? Is this, so parm top, permit parm top, and now we're having the same shit. I am so lost right now. Could it be that you have to specify the file path? Like that? No. Yeah, all of this looks fine. Amber 22.5. I've done this before though. Bro, I'm so lost. It was just working. Why did I delete those files? Something very strange is happening. Okay. So we just made the IMP, CRD, and palm top. So I'll just copy this whole thing. INP CRD. It's frozen. Great. Awesome. Alex. All right. So let's get these files over one more time. Conda activate. I'll do yeah, it's Amber. Tleap, what is that? Tleap. Okay, so we just made that and that. Okay. So open this. Then drag this to here. Replace, replace, replace. Okay. Now we're not going to touch anything until this thing's fully sent over. Now that I think about it, I might have actually had something like this happen in the past. And I might have to do something like that. Where I put a $ and period in front. I'll just do the full shebang. So so we'll go to, what's the first one? min-watt here. And we'll add these file paths, and then we are right here. And then I'll just copy this. So we gotta do that. If this was the issue, I'm gonna freak out. Um, okay. Could not open. Oh, I see. Of course. What do you mean, invalid memory reference? Like, I'm stumped. We could test something though. Like, does this submit right here? Turn on 4. So this is the job I'm submitting there. Okay. So if this runs, then there's something wrong with the files themselves. But if this doesn't run, then there's something wrong with the supercomputer. 136981, 36981, yeah. This is 34310. 34310, yeah. So the files are no different. And the job is running on the other thing. Let me request access to a GPU. CPUs per task, mem. All right. So time, I'll just do like literally 10 minutes, 20 minutes. Mem 320 and we'll do CPUs per task 24 nodes 1 gress equals GPU 1. Does this work? Let me see how this does. All I want is 20 minutes. All right, what can I do in the meantime? I guess load this to the supercomputer. I need to do this though. Or this. Oh, here we go. All right, so I should be able to just do min chmod +x min watt.sh. Wow. I don't know what's going on. Let's remove all DNA shit. I don't need any of that stuff. Let's get this back over. Something's getting mixed up somewhere. Jesus Christ. Maybe it is. So we'll go to starter files. Menwat all. No, menwat. So let me copy and paste these over. Replace. These are all new files. Why is this taking forever? It's probably something so simple. Alright, so what I'm going to do is back out and go back into this. And I'm going to do Shift Command. No, I'm not going to do that. But I am going to run this. Please. Oh my god. Anybody out there, if you know what's going on. It's kind of strange that this is taking so long to save. I think I just removed this directory and then put it back in. That's the only thing I could think of. So I'm going to do that. Is there anything I need in here? No. Okay. Shift Command P, reload window. All right. And then we are going to go here. So let's remove these. Just remove DNA PG linked. Do we need anything? Yeah, remove all the links. And then do tleap again. Okay, look at this. Looks reasonable. All right, and we're going to open this. Go here. Reload the window again. Then we're going to drag over this directory into here. And we're going to wait and be patient. Hopefully this doesn't take 16 minutes. So that's how long we have of the GPU. All right. So here we can solvate and add ions. So how do I do that? This. Yeah, should be that. I think so. Go Psi4, tleap. Oh, I need to load Amber. What? Oh, we need to load the ions here. What? Oh, I see. Okay, you do AA. There. Then we should have this in a box. Yeah. Well, I didn't know the Mol2 was like this detail. It's kind of cool. I usually just do a PDB. I like that. All right, is this done loading? Okay. How much time do we have? 8 minutes. CD Alex. Okay, so what we need to drag over is this starter files. So what we want is the min watt.in. So well as the minwat.sh. Okay, and we want to change this so that we use those things. So this here, this there, and the ref can change. All right. Let's wait a second. Why does it take so long? Thank you. All right, so do module force purge, module here. Okay, now cross your fingers. Of course. All right, I have no idea what's going on then. It has to be something with the build of this. There's got to be something with the tea leaf. We're not doing something right. Do you see anything wrong here that would create this error? Here is the tleap script. Here is the tleap output. Here is the submission script. Here is the .md out. All right, I gave it everything. What if we change this? There's no way. Okay. I was about to get pissed off. The bonding topology in TLEAP is wrong, creating bonds that overlap. I might need to change the names of the bond types, maybe. The thing is, like, I've ran minimization through this before. So that doesn't really make sense. Invalid memory reference. Do I really need that? Oh. Request it again. Do this. Save mul 2 1. I doubt it's the close contact, because like I've done stuff like that before. What is unusual is that I have ran MD It seems this is happening randomly. Oh, could that be it? That could be it. Because are there even any CACON? Yeah, there's not even any of those there. That could be the problem. And I've actually deleted the restraint mask before and it went through. Give me the compute. Does heating have the same thing? Heating doesn't have a restraint mass though. So that might not be the solution. All right, let's see if this will run though. What do we got here? So we can throw this in the supercomputer as well. Let's see what this tutorial here does. Here, maybe it could be that Amber doesn't use like, I don't know. Like, why do they use OPC water? Is that just a preference? Mm. Yeah, they use tip 3P. So this is their minimization. So I could try that. If it'd give me the freaking compute. What about like explicit solvent? Do they do that? That's implicit solvent. You know, that results are very susceptible to long-range cutoff, with no cutoff giving. The instability is attributed to the in vacuum simulation. Hmm. There we go. All right, so let me create another terminal here. And then we're gonna add, where are we? Two, go to our starter files. Here. So we're gonna add minwatt.in to that. We also want to add this. Okay, then we'll change so we got this here, that, and that. Ooh, I wonder, another thing too is if it's reading from these, should it output that? So maybe we could change this to this. I don't foresee any troubles with this one though, but who the hell knows? But if I could get both these simulations to work, then that'd be really cool. I would have learned a lot there. Let's look here. The problems with bad van der Waal and electrostatic interactions in the initial structure that led to the need to minimize our in vacuum structure, completely magnified when we start an explicit solvent. to the system. We then added a truncated. This water has not felt the influence of solvent or charges, and moreover, there are many gaps between. If we are not careful, such holes can lead to vacuum bubbles and instability. Thus, we need to run a careful minimization before slowly heating our system. Allow water to relax prior to running. Come on, brother. First, we'll keep the DNA fixed and just minimize positions. The belly option. Minimization's turned on. Usually do 500 steepest descent minimization. Constant volume. I mean, is that everything that's in here? Oh, shit. Alright, I gotta go, guys. Sorry.